guys, I hope you are doing well. At this session we're gonna begin with rectangles. By click and drag, I dock the window here, window rectangles. As you can see, we got a few commands here. By this way we can specify the two corners of the rectangle. Then by this command we can sketch the rectangle from the center, which it is center based. And note that in Rhino, objects or geometries like rectangles got their centers. Check this out. While in other softwares you may have it only for the circles. And the next one is rectangle by 3 points, which is very practical in many cases. Start of edge, then end of edge, and then you can specify the width by specifying the value for the length. The next one is rectangle vertical. We can have a vertical rectangle in the scene. I pick the command. As you can see, we got the green and red axis. This will be the result, which is perpendicular to the C plane or ground plane. And the next one is rounded rectangle. At the corners got fillet. Check it out. You can add fillets to the corners. Then it will be like an ellipse or ellipse. In the continuation, I'm gonna go through more details. Here, if I wanna use a rectangle corner to corner, at first I specify 0 for the origin point, or we can enable the grid snap for specifying the two corners of the rectangle, or you can specify the coordinates and estimated coordinates actually. For example, for the X, I want to consider 30 and 25 for Y. I add sign 30, 25. Check this out. Then enter for finishing the sketch by specifying the coordinates. And the next one is rectangle by center. I specify 0 for the origin point, and then I can specify the other corners or length. That if you hold down shift while sketching a rectangle, you can have the four sides equal to each other, or sketching a square. Only hold down shift. At this condition, F8 is different to shift. And the next one is rectangle by 3 points, which can be practical and useful for the conditions that you need to work in the perspective view. Like to say, let me give you an example. I sketch a rectangle like this, and the another one there. By this way, I move it upwards. Then by 3 points, I can specify the corners and the midpoint as the 3 points of my new rectangle. Check this out. By this way, let us give you another example. Like to say, for the rectangles which have been rotated, I pick 2 points. I specify the edge of the first edge by specifying the angle, the less than symbol, 45 degrees, and then for the end of the edge, so at first I specify the angle, then the length, and then the width. By this way, by using this technique, you can have your rectangle in an angled manner. Suppose that we got some geometries like this, and then we want to have a rectangle between these two, like this. And the last one, which got fillet at the corners, or the rounded rectangle. After sketching that, we can adjust the fillets. We can specify radius or point for rounded corners to pass through. For example, for the radius, I can specify 5. Enter. By the movement of mouse, you can adjust the fillets of the corners without specifying a value for the radius of the corners. And the next topic that I want to talk about is the polygons. And then I move the window. Note that if the amount of the commands was few, maximize the size of the window, then you can see the other commands. The first one is polygon center radius, and we got 3 techniques for sketching the polygons. This is the first one. Let's check it out. That when we are sketching the polygon like this, as you can see, we got the number of the sides, which is 4. I click on it. For example, 8 sides. Here, as you can see, I can specify the corner of the polygon, and the marker of the mouse is exactly on the vertex of the polygon. Here we can specify the radius, for example, like 40, and then the angle. We can specify the position of the vertex that we are moving it, or we can hold down shift to restrict the movement. So the marker of the mouse was exactly on the vertex. And the next one is the circumscribe polygon. Then by using the next approach, when we specify the center of the polygon, then as you can see, the marker of the mouse is positioned at the midpoint of the polygon edge. And when we specify the amount of radius, the value would be the distance between the midpoint to the polygon edge, which is the circumscribed circle. Well, the previous one was inscribe, but we don't want to focus on this circumscribe and the inscribe polygons, since I want to focus on their applications and their functions in order to teach you something practical. And as you can see, we can control the midpoint of the polygon edge. If I specify 4D and then upwards, let me turn on the center grid snap. As you can see, the value of radius is 4D from the center to the edge point, midpoint actually, while here 4D is the distance between the center to the vertex. This is the differences between these two. The next one is polygon by edge, that we specify the length of one of the sides by specifying the start and end of edge. And then based on the specified distance between the 2 points or edges, you can have your polygon 30 degrees and then the 30 meters for the length. Check this out. And the another one is a square center corner that we have worked on it before. It is repetitive. The number of the sides is 4. If I specify 8, then check this out. So as you can see, these three are similar to the previous ones. And about the option, we don't have any specific things, but number of the sides and the modes of inscribed or circumscribe. For example, you can modify the mode of inscribe to circumscribe or edge, which is this one, the third one, polygon by edge. And the last one is star. Let me give you an example by using star. I pick the star command, then I specify the center, which is the origin point, and then this would be the result. You can sketch a star with it. And about the settings or option, we got the number of the sides, vertical and around curve. For example, 8 for the number of the sides. Then after sketching the star, we will have 16 sides, 8 for interior and exterior each, by this way. And for vertical, that we can sketch it vertically in the perspective, perpendicular to the current plane, like this, that you don't have to hold down shift, control, or sketch in the front view. But you need to specify 2 radius for it, the origin point for the center, then the corner 30, then the angle, I hold down shift, the second star radius, I specify 25, like this. Check this out. Or if I want to give you another example about this case, for instance, if I modify the number of the sides and set 25 for example, then we will have 50 sides. Then I want to curve it. Let's check it out. And then I want to design a column. Let me show you in the preview of the rendered view, like this. Well done, we're finished with the arcs and the squares, polygons, and all of the 2D drawings geometries. Don't forget to take some time on practicing them. Also the examples, don't forget to take notes and try to practice each of the examples one by one. Well done. In the new part, after getting skilled at the 2D drawings, we're gonna go through Gumball, as you can see, but it is different to the amazing world of Gumball. I draw a box or a circle, it doesn't matter. When we select the objects, here as you can see, we got some arrows, some arcs, some shape handles for moving. This is called Gumball. So if you have selected your object in the scene and the Gumball was not displayed, you should activate it. As you can see, we can enable it or disable it by click. But we're gonna talk about the applications of the Gumball and the functions. What is the purposes of creating Gumball? First of all, we use these arrows, the blue, red and green arrows for moving the object in Rhino. For example, I want to move the box along the z-axis, so I hold the marker of the mouse and the blue marker arrow actually, and when it turns to black, I click on it. Then by drag, note that I do not release the the mouse button. By click and drag, we can move it, or for example, along the x-axis. I mean y-axis, or along the x-axis. Here, as you can see, there is a plane which is divided into 4 parts. By this plane, we can move the object along 2 axes simultaneously. That as I modify the view, the place of the plane will be changed. For example, here we can modify the position along the x and y axis, while at this view we can change the position along the z and y axis. And in the 2D views, we got only one option for the movement. So by using the arrows or the handles, we can move the object along only one axis, while if we use the plane, we can move the object along 2 axes simultaneously. But while you are moving the object, if you hold down Alt button, you can make a copy or duplicate. I hold down Alt and then I move the object by the handle. As you can see, I can duplicate or make some copy from the object. I select all of them, hold down Alt, then by click and drag I move them to make some duplications. Check this out. I can move and copy. Undo. Here you may ask, how do we can move our object in the specified distance or coordinations? At first, you should select your object. Then you should have a single click on your desired axis. For example, z-axis. Then after a single click, you can specify the coordination or coordinates, 15 for example. So the object is moved based on the specified value. I click on the green axis, 60. It will be moved. And note that the unit is your specified unit project. But right now, before clicking on the axis, on the green axis for example, if I hold down Alt and then if I click on the arrow or axis, it moves the object and copies as well. As you can see, we got a duplication here. So this was all about moving the object. And the other option is rotation by using these arcs, which is very simple. That we can use click and drag and then rotate the object along the Z, X and Y axis. But don't forget to consider the color of the axis. For example, if I want to rotate the object along the Z axis, I should choose the color of blue. Then I can rotate it along the Z axis, as you can see, actually around the Z axis. Or if I want to rotate it around this X axis, we can use the red one, as you can see, like this. And right now here, if I hold down Alt, I can rotate the object, meanwhile making a copy. As you can see, I'm making duplications, and if I want to specify the value, I click on the arc. Then I can specify the value for the rotation. Check this out. Here, if I specify 20 degrees, it will be rotated anti-clockwise. And if I specify minus 20 degrees, the rotation will be clockwise. That, as I told you before, we can add the positive value for the anti-clockwise rotations and negative values for the clockwise rotations. And while you are rotating the object, if you enable F8, it restricts the rotation at each 90 degrees angles. I mean, if you enable ortho, check this out, if you hold down Shift, it restricts the rotation at the specified angles. However, you can enter the value manually without using of ortho. Unlike moving, if you hold down Alt and then click on the rotation, we can make copy. Check this out, the copy is created. As you can see, we got some duplications. Meanwhile, the object is rotating in the specified value, we can have some duplications. And the next option here is scale. Again, if I select the object in order to get access to the Gumball, by using these squares, as you can see, these enables us to scale the object or minimize or maximize the size. For example, we can scale the object along the y-axis or along the x-axis, as you can see, by this way. But while you are scaling your object or modifying the size of the object, if you hold down Shift, then I can scale my object in the X, Y and Z directions simultaneously. Let me give you an example by the line. And since here we got a 2D drawing, we don't have the scale option in the Z direction, but I can scale it the X and Y directions like this. And if I hold down shift, this will be the result. We can scale the geometry in the X and Z, X and Y directions. What about specifying the scale manually? Here if I click on the square, you can specify the multiplication for the scale. For example 2, the size will be multiplied in 2. Or for example if I specify 0.5, check this out. The specified value here is the ratio that the size will be multiplied in 2, 3, 0.5, and here again if we hold down Alt we can make a copy or duplication. I can hold down Alt and then make some copies, or we can hold down Alt and then click by this way. And here there is a point that I should say. Let me sketch a mass or a model geometry which is not mirrored or identical. If I want to modify the scale of this geometry, for example, in the z-axis or direction, if I specify -1, it mirrors the geometry. Check this out. As I showed you, the geometry was rotated or mirrored. But here you may ask a question that while we are rotating the geometry or object, like this, as you can see, the rotation is based on the gumball position, and even when we scale the object, check this out, the scaling is based on the position of the gumball, as you can see. But can we modify the position of the gumball? Of course we can. Here if I hold down Control button, right now I hold down Control button but I do not click, and then I hold the marker of the mouse there. Then by click and drag I can modify the position or move the gumball and then place it here, for example. Again I hold down Control, then by click and drag I can move the gumball or the pivot point. It is called pivot point in some of the softwares. Then you can place it wherever you want by using the snaps, and then there would be considered as the pivot point of the scale, rotation, and the movement. But if you wanted to reset it to its default place or to the default position, here there is a white circle, as you can see. If you click on this, then it enables you to reset the gumball. If I click on reset, it will return to its default position like this, as you can see. And the next point about gumball is that when you select your object to rotate it like this, the gumball is rotated temporarily, as you witness. As you are concerned. If I deselect it and then select it again, then the direction of the gumball will be adjusted to the international directions. It is parallel to the international directions or to the coordinates. But if we want the gumball to be rotated along with the object, I should click on the white circle and then I should enable align to object. Right now, as you can see, the gumball is aligned to the work plane or to the current plane. But if I align it to the object, and if you wanted to customize the position of your gumball, then you can hold down Control, by click and drag, you can relocate it. So if you enable the align to object, the gumball will be aligned to the object when you rotate your object. And then if you wanted to reset your gumball, you can click on reset gumball, then it will be returned to the previous position. And if you want it to be aligned to the work plane, right click and then choose align to C plane, like this. And we usually align the gumball to the work plane or current plane, that sometimes when it was needed we can align the gumball to the object. Very well, but about the other topics about gumball and points that I consider gumball very useful, mostly in lines and curves, is extrude. Here if I select the curve, here we got some circle, some solid circle in the coordinates, on the coordinates. For example, here we can extrude this rectangle along the z-axis. So we got this circle only on the z direction. If I click on it, click and drag, and the other capability of the gumball is its behavior with the 2D drawings. Let's check it out. For instance, here I sketch a rectangle. Then if I select the rectangle, then on the z-axis we got a circle, as you can see. If I click on that circle or that solid, and when it turns to black, I'm talking about the circle, not the arrow. I click on it when it turns to black, but I do not release the button. Then I drag it upwards. Then I can extrude the 2D drawing. Then we can have a box. So this was the extrusion process. Making the extrusion. Let us try again. I disable grid snap. I select the rectangle. Then along the z-axis, I click and drag the circle. Then I extrude the circle. Rectangle. So this creates the extrusion. Here I can specify the value manually by clicking on it, for example like 15. By this way we can extrude the rectangle. Actually this process, which is done by Gumball. By using Gumball we can create lines from the points, check this out. Then we can create surfaces by the lines, check this out. And if I explode the box, let's check it out. However, this is not related to our today's lesson, but I want to show you. Here if I extrude the surfaces, I can have boxes out of them by this way. While I was extruding an object, for example this rectangle, if I hold down shift, I'll have the extrusion at the both sides. I hold down shift and then I release it, check this out, the differences. The extrusion normally is at the one side. But if I hold down shift, then it extrudes the line at the both sides. You should not hold down the shift from the the beginning of the process. At first, I click on the circle, then I drag it, then I hold down shift. Then we have the extrusion in both sides. So by this way, we can have extrusions in two sides, like this. In the continuation, I'm going to talk about the commands that you can have in the command line and they are related to the Gumball. You can either use Gumball or you can have the command from the command line. For example, the first one was moving. Check this out. Here we can move the object by using Gumball. But how can I get access to this command? Enter, move, point to move. Then if I want to move my object after starting the command, I should specify a point in the object to move it. Then I should specify the distance of the movement and also the direction of the movement, as you can see on the screen. For example, 60 meters in the 30 degrees angle. So the less than symbol, 30 enter, 60 enter. And then I move the object after specifying the direction. Enter, then I should specify a point as the pivot point. You don't have to specify it exactly on the object, like this way. Then I should specify the amount of movement and then the direction of the movement. However, you can move your object vertically, Then you can move your object along the z-axis or in the z direction, as you see. Well done. And the next command is rotation, as you are concerned, that we used Gumball for rotating the object. Here I can search for RO, then I enter, I press enter actually, then I should specify the center of rotation. That when we were using Gumball, the Gumball itself was considered as the pivot point in the rotation process. But I specified the center of rotation here, then I should specify your start point of the rotation, and then I specify the angle of rotation. That I chose you the positive and the negative values of the angle and the direction of rotation. For example, minus 45 degrees in order to rotate it clockwise, like this, as you can see. And you can choose to make a copy from the object or not. As you can see, copy no. And you can use last center or not. If you enable use last center, you can use the last center for your new process of rotation. And the next option is copy, which is very simple. CO, enter. I start the command of copy, just like moving, from the origin point. Then you make a copy, the less than symbol, 45 degrees, and then, for example, 80 meters. Check this out. Then we will have the duplication, and then if you click, the object will be placed. And the another option here is use last direction, as I'm pinpointing with the mouse. If I specify yes, it preserves the direction, so we can have more duplications like this. at the last direction. Here even you can use last distance. I enable it, check this out, by this way. And as you're concerned, this is very simple command as we were working with Gumball, but I just wanted to tell you some extra points about it. And the next item or option is scale. Here in Gumball, as I mentioned before, we use these squares for scaling the object in the specified directions X, Y, and Z. But if I hold down Shift, I can scale the object in the 3 directions. Well, if I want to search for it in the command line, C, here we got 3 scales, scale 1D or 1 dimensional. I click on it, I specify the object, then I should specify the point, then the second point, check this out, then I can scale the object in only 1 direction. So this is the 1D scale, which is similar to stretch, and the second one was scale 2 dimensional or scale 2D, which wasn't offered by Gumball, in 2 directions. I select the object and I specify the point, the first point and then the second point. Then we can scale the object in 2 directions, X and Y. I mean the height is fixed. As you can see, we are scaling the object in the X and Y directions. And if we use scale, we can scale the object in 3 directions, X, Y, and Z. Like this, as you can see on this screen. In the continuation, let's check out the parameters. For example, I'm going to start from scale 1D. I select the object, then I should specify the base point, like this. We got 2 approaches for scaling our objects. It does not make difference, 1D, 2D, or 3D. This is similar or fixed. I specify the base point, and then I can specify the ratio, scale factor, or first reference point. For example, I specify 2 to multiply it in 2. Check this out, the scale factor. Then I should specify the scale direction, like this way. By this way, you can specify your scale direction, like this. Let us try again. Scale 1D. Then I specify my object to scale. Then I should specify the base point, which is fixed. Then the scale factor, or the first reference point, 0.5. And since the direction has not been specified correctly, actually, it looks strange. But if I want to have the height, I move it upwards, or in the Z direction, X direction, Y direction, the scale factor will be considered. And in the next type, we do not specify the scale factor or in a scale reference. I mean, it is similar to scale reference in AutoCAD. In this process, at first we specify the base point and then the second reference point. After that, we can specify our desired scale factor or value like 25. Let's try again. I don't know what is the height of this object exactly, but I want to consider a specific value for the height of this object. For example, I want it to be 18. So scale 1D, specifying the base point, then the second reference point, for example, 18. Then the value of 18 will be applied as the height of the object. I mean, we can either specify the scale factor or the reference point. Let us try this for the 2D and 3D scale. For example, scale 2D. Then I select the object. Then the base point I should specify. Then I should specify the scale factor or the reference point. Then it will be scaled in 2 directions, X and Y. Here in front viewport, if I select the object and then I specify 2 as the scale factor, then the scale will be in the directions of Z and Y. But what about the reference point? I specify the object and the base point. After that, I measure a specific distance. Then I want to specify the new value for it, which is the reference point. For example, 30. Then the scale, the object will be scaled in 30 meters. And we got it in the 3D view, just like we told you before. I specify the object and the base point, then the ratio or scale factor. Or I specify the reference point and then I enter the value, like 30. Let me choose another value, like 50. Then the other reference points will be scaled in the X, Y, and Z directions based on the entered value. Guys, we're finished with this session. Please don't forget to practice the given lessons. If you had any questions, you can ask me. And after getting mastered in these, we can start the next session. So do not skip the most important parts and watch them attentively.